Hi guys, so this is the second of my videos on solubility and solubility products. So another thing you're going to have to do for the AP exam is to compare the solubilities of equal ratio salts using KSP values. What that means is that if you have 2 or 3 salts where the ratios of their ions are the same, just by looking at their KSP values, can you know which one is more soluble or less soluble? So what I've looked at here, starting up here at the top, is our compound from video 1, nickel carbonate. It dissociates into nickel 2 plus and carbonate ion. The ratio of this, as you can see, is 1 to 1 to 1. For every molecule of this, you get one of these and one of these. You're also given a KSP value, which is this, 1.4 times 10 to the minus 7. As you can see, very, very small. This is my equilibrium expression. So we can put it into an ice table. Now, it doesn't matter what your starting concentration of this is. That is because this is so small that this is not going to change appreciably as a result. So it more or less does not matter how many moles of your starting substance you start with, and it also doesn't matter because you don't have it in your equilibrium expression anyway. Whereas the ion concentrations, they start at 0, and because the ratio is 1 to 1, you're going to have plus X here, plus X here. I included this just to show you my thinking. So you have minus X here, you'd have 1 minus X, which is equal to or approximately 1, because this number is so small. So that being done, you can then use your KSP value, 1.4 times 10 to the minus 7, and put it into your equilibrium expression. And as you can see, it's just X squared. X times X, X squared. Now you do the square root of both sides, and what you find is that X is equal to 3.74 times 10 to the minus 4 moles. So that means that you can expect to have at equilibrium, so your solid has been dumped into the water and you're at equilibrium, you can expect to have this many moles of each of these ions, okay? Now, something important to note, the molar solubility is going to be equal to X. The molar solubility of a salt, of a solid substance that does not dissolve easily, is going to be equal to X. This is because X is always going to be, say, your lowest number, the 1, shall we say. So for every molecule of this, you are going to have 1X. And what that means is that whatever your value of X, that's going to be your molar solubility in moles per litre. Okay? We'll talk a little bit more about that after, but just wanted to show you that now. Now, the point of this question then, if we look at another ionic substance, say iron oxalate, which is also 1 to 1 to 1. One of these makes 1 iron and 1 oxalate ion. You look at the KSP, 2.1 times 10 to the minus 7, and because the ratio is the same as for this compound, you can look at their KSP values and then decide which one is more soluble. The bigger the KSP value, the more soluble the substance. The bigger the KSP value, the more soluble the substance, because that means you have more of these ions existing in solution, which means the solid was more soluble to begin with. Okay, so with that in mind, we look at this iron oxalate and see 2.1 times 10 to the minus 7, and we look at our nickel carbonate and see 1.4 times 10 to the minus 7. This is clearly more soluble. Just by knowing that the ratio of their ions are the same, you can look at the KSP values and just instantly know which is more soluble. When the salts that you're comparing do not have the same ratios of ions, you must write out the equilibrium expression, feed your numbers in from the KSP, and then calculate it for yourself. I hope that's clear.